Okay, we will be starting with the session now. Hello, everyone. Dear authors and invited guests, welcome to Technical Session 6B. My name is Dimahi Patel and I will be the moderator for this session. On behalf of Global Knowledge Research Foundation and JR Scholastic LLP, it is my great pleasure to welcome you to the International Conference on Machine and Computing Technologies for Sustainable Development, that is MCT4SD 2025, Manila, Philippines. The conference is being organized in a hybrid mode. The physical event was held in Manila, and the virtual event is being held through Zoom yesterday and today, that is 12th and 13th December 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 8 presentations. Each presenter will be given 12 minutes for presentation and 3 minutes for question and answers. On 10 minutes, a gentle reminder will be raised. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to us in the chat box. I would like to introduce you all to the chair of the session. We have with us Dr. Melody C. De Vera. Dr. Melody serves as the head of the Statistics Center at Pangasinan State University, PSU, main campus in Lingayen, Philippines. A key figure in PSU's research and statistical endeavors, with recognition in university publications and directories for her leadership in this vital center. A warm welcome to you, ma'am, and I request you to share a few words you may have for the presenters today.
Hello, good afternoon to everyone. Welcome to this session, and I am privileged to be your session chair. We have series of insightful presentation lined up today, each showcasing research that contributes to advancing technology integration and emerging challenges in different fields. As the presenters share their work, I encourage all participants to engage actively. Some questions later will deepen our discussion after each presentation. Let us give the presenters our full attention and support. With that, again, a good day to everyone, and let's begin the presentation.
Yes, thank you, ma'am. We also have with us Dr. Aneri Kilol Pandya as our session chair. Dr. Aneri is an assistant professor at CSPIT, Charasat University, Gujarat, India, with over 13 years of experience in academic experience. She has made notable research contributions, publishing 20 papers across reputed journals and conferences. And her areas of expertise include the Internet of Things, microprocessors, microcontroller technologies, and metamaterial antenna design. She continues to advance her research and teaching with a strong commitment to innovation and academic excellence. Welcome, ma'am, and please share a remark you may have for the presenters here. All right, we will be starting with the presentations then. First up, we have Zarif Vasif Bhuyan. Zarif, sir, are you present with us?
Yes.
Yes, sir. Please present your study on a comprehensive analysis of deep and traditional machine learning for kidney diseases and lung cancer CT interpretation.
Hello. Good afternoon. I am Jaipur Bhuya. Today I am presenting our work using deep learning and traditional machine learning to interpret CT scan for kidney disease and lung cancer. Our goal is to improve disease detection using AI to enhancing diagnostic accuracy. In this presentation, we will cover challenging in multi-organ CT recognition, the current state of AI in medical imaging, gap in existing research, our methodology, experimental result, and comparison with other studies. CT scans are vital of diagnosing kidney and lung diseases. However, AI models faces challenges include different in scenarios inconsistent image processing and model design for only one organ. This issue make it hard for AI to work consistently across patients. Uh, our goal is to create an AI-based uh, goal is to create an AI system that uh, perform accurately and fairly for both kidney and lung diseases, while also being easy to integrate into current medical workflow. We created a data set of 10,500 CT images covering various kidney and lung diseases. We deployed a clinical robustness pipeline, a custom CNN architecture. Our model achieved 97% accuracy, showing its potential of clinical uses. AI, particularly deep learning, has shown good result in detecting kidney and lung diseases. However, many models struggle to generalize across different organs, making AI application challenging in healthcare. Many studies have shown strong performance in kidney and lung disease detection. However, most focus on just one organ and lack external validation, which limits their use in real-world scenario. Current research has gaps, such as a small dataset, inconsistent evaluation metrics, and lack of multi-organ models. Our research addresses this through balanced patient-wise splits, cross-organ estimation, and clear evaluation metrics. Our app, uh, our approach involved collecting a large dataset, pre-processing the image, and evaluating model. We use deep learning model like V16, SZ50, uh, alongside traditional machine learning like SVM, random forest for comparison. Our dataset consists of 10,500 images across 7 categories, 5 kidney diseases, and 3 lung cancer. The dataset was split into training, validation, and test sets, ensuring balanced represented of all categories. Our dataset covers common diseases in both kidney and lungs, chosen for their importance in medical imaging. We use windowing and to improve image visualization, downsizing to reduce noise, normalization to standards, scanning difference, and augmentation to make the model more robust by adding variation of the data. Our custom scene is designed for multi-organ CT recognition. It uses convolution layers, max pooling, dropout, and class balance mini batches to help the model learn effectively across different disease categories. We compared our custom CNN with other deep learning models like ResNet 50 and BA16 and traditional machine learning like SVM, Reinforced, and DSMT to evaluate the strength and weakness of each. ResNet 50 and BA16 performed well but showed minimal overfitting. Our custom CNN had more gradual learning curve but performed strongly, especially in kidney disease categories. Traditional model like SVM, Reno Forest, and Distribution perform more uh, materially, but struggle with complex cases, particularly in distinguished lung cancer uh, subtypes. The custom CNN achieved perfect score for kidney disease and performed well with lung cancer subtypes, providing its robustness in recognizing various diseases accurately. While traditional machine learning models show some success, they are less effective than deep learning model, particularly in distinguished lung cancer subtypes. Compared to other studies, our approach stands out. We used a multi-organ dataset with patient-wise dispute and caliber preprocessing, which result in our model achieving 97% accuracy out from other with a smaller dataset. To conclude, our unified pipeline achieved 97% accuracy across kidney and lung diseases. We have developed a balanced, interpretable system ready for deployment. Future work include extended validation, clinical workflow, including and 3D videos for better volumetric analysis. This reference supports our research covering relevant studies and dataset for kidney and lung cancer detection using AI. Further reference are kidney diseases, kidney, lung cancer, and AI-based image recognition. Thank you for your time and attention. Feel free to ask any question.
Any questions, ma'am? Melody, ma'am, any questions?
Yes.
Hello.
Congratulations to our first presenter because the paper addresses practical and important challenge in medical AI. Inclusion of both deep learning and traditional machine learning provides comprehensive benchmarking. I have a question on the data sources. Are your sources are these public data sets, or what are your inclusion and exclusion criteria on your data sets?
Our dataset is public dataset. We collect from public available data.
Were images from different scanners or acquisition protocols included?
Sorry.
The images, are they from different scanners or they were acquired with protocols included?
These images all are CT scan. CT scan
Oh.
image, lung and kidney.
What motivated you to choose CNN as architectural choice?
Basically, we want to make a system where we scan the CT scan or any type of scan, so the machine takes show that this is the problem, this is their primary scan. So when he done in primary scan, then he or she go to that doctor to for high treatment.
Okay, thank you.
Anedi, ma'am, any questions for him?
Yes. Okay. First of all, I'm welcoming you on the session. Now, the question from my side is that your data size, which you have mentioned, you have taken the 10,500 images of CT scan. So, whether your data size will be performing or it will be affecting your ML comparison model?
Dataset is maybe from my side, dataset is not big, dataset is small. We need many dataset so that accuracy maybe increase. But we have computation less computation power, so we take small dataset. If we take many dataset, the we feel that our model is more comprehensive.
Okay, and what are the future expectation or what are the future scopes or working process you are finding
we are
from
planning
this?
we are planning to make a device that IT device that is can is can peria CT scan or other thing and detect the problem, which is I called we call that pre-scanning, and
Okay.
then he or she go to doctor.
And you have compared the model with the different architectures and parameter size, or how you have trained the model? Which
Uh,
parameters you have taken into consideration?
we here you see horizontal architecture, basically.
Hmm.
We here use 5 layer, double layer, 30 to 32 double layer, 60 to 60 double layer. So we compare with P10 model, less than 50 V16 with our model. Our model is heavy, but our model is very much a good result in other model.
Okay, thank you.
Welcome.
Yes, thank you so much, sir.
Welcome.
Now, before we continue, I would like to thank Dr. Aneli Kilor Pandya for joining us as our session chair. Please allow me to introduce her. Dr. Aneri is an assistant professor at CSPIT Charosat University, Gujarat, India, with over 13 years of academic experience. She has made notable research contributions, publishing 20 papers across reputed journals and conferences. Her areas of expertise include the Internet of Things, microprocessor and microcontroller technologies, and metamaterial antenna design. She continues to advance her research and teaching with a strong commitment to innovation and academic excellence. I welcome you, ma'am, and please share a welcome remark for the presenters today.
Okay, thank you for the good introduction. And we today we have a wonderful set of presentation which will cover the AI, machine learning, and augmentation, IoT, security. So I would like to thank the organizing team for inviting me as a session chair. And it's been an honor to be a part of MCT4SD 2025. And I'm looking forward to have an excellent presentation from the presenter. And all the best to all the participants. Thank you.
Thank you, ma'am. Now, continuing, I would like to call C. Sharmila. Sharmila, ma'am, are you here with us?
Yes, ma'am, I'm available.
Yes, ma'am. Please present your study on an explainable multimodal system for detecting fake profiles and enhancing candidate recommendation.
So, good afternoon, everyone, and I am Sharmila, and I am here to present on a topic titled An Explainable Multimodal System for Detecting Fake Profiles and Enhancing the Candidate Recommendation. So, our problem statement is that nowadays LinkedIn are flooded with fake profiles, which were generated using LLMs like ChatGPT. So, this will waste the recruiters' times, and they also enable scams and mislead the companies, and also it can break the trust of the hiring process. And existing methods often rely on text-based analysis only, and also they lack transparency. So we introduced a new multimodal feature system which combines the text data, numeric data, and as well as the graph-based data. And we also have a two-level hierarchical classifier which classifies the deceptive profiles from the fake profiles. And we incorporate SAP-based interpretation for the fake profiles. And also, finally, we incorporated a recommendation system for the HR side. So our objective is to create a two-level XGBoost model which accurately detects the genuine and fake profiles. And also we provide interpretation through the SHA-based explanation. And finally, we provide a trustworthy candidate recommendation using SBOT and ANN only from the verified genuine profiles that we will store in the SQLite database. So we have surveyed many papers and let us see some of them. For the first paper is detecting deceptive identities. Here they have used many classifiers and they have used Kaggle dataset. So here they have achieved a 92.5% accuracy. They have used multiple classifiers to choose the one which is best for their approach. And the future enhancement they had suggested us to expand the dataset and to integrate the NLP-based techniques and graph-based approaches. The second paper is that the looming threat of fake and LLM generated LinkedIn profiles. Here also they have used many machine learning models to detect the one which is best for them. And here they have introduced new SST method, which is section and subsection tag embedding. They are the one who publicly released the data set which contains 3,600 profiles, and we have used this data set for our project. The future enhancement includes to detect the genuine profiles which are generated by the LLMs, and also to improve our training with synthetic data and to integrate the explainability. So now let us see the architecture of the proposed system. So we have two web dashboards. One is for the candidate and the other is for the HR. In the candidate side, they can log in and upload their resume. The resume can be in any format like PDF or a document format. So after uploading their resume, it can be parsed using NLP based techniques using sparse EY. And then we pre-process and extract the features like numeric text and graph. After we input this data to the model which we had trained, so the first level will classify whether it is genuine or fake, and then the second level classifies the fake or human written fake or GPT fake. These are classified using a probability score, and then if it is fake, we give a SHA based explanation, or if it is genuine, we simply add it to the genuine database, which will be helpful for the HR side. In the HR side, they can log in. The HR can log in and upload the job description. After uploading, he can enter how much candidate he want. Like can enter top five candidate, top 10 or top 15, and then we use ANN, which is approximate nearest neighbor. Using that, we can match with the genuine DB, which is already we stored in the candidate side, and we using a similarity score, we offer top end candidates to the HR side. So now let us see the models one by one. The first model is candidate profile input and pre-processing model. Here we upload our resume on the candidate side, and it is parsed using PDF plumber like tools, and we use NLP based techniques to extract the contents that is relevant to our project. So the second model is fake profile detection model. So we already trained the XGBoost using two levels. One is the authenticity gate, which is level 1, which detects genuine and fake. And the level 2 is deception sorter, which classifies a human fake and AI generated fake. And we have used XGBoost for this classification, where it outperformed well, achieving nearly 99% accuracy. And the third model is explainability model. We have used a SHARP for this explanation. So the HR can understand why it is flagged as deceptive. So it can be due to followers, connections, or number of experiences, activities, interest, or recommendations. And we can see through this visualization. The fourth model is input and matching model of job description. So here the HR can give their job description to identify the candidates that they are looking for. So here we use SBERT and ANN. SBERT is used for converting these description into embeddings and the approximate nearest neighbors to find which are most relevant to their job description. So the final module is candidate recommendation module. Here we rank the top N candidates to the HR side with the semantic similarity score so that they can understand who are relevant to their job description. So these are the libraries that we have used for our project. For the front end, we have used HTML, CSS, JavaScript, Bootstrap, and Jinja 2. For the back end, we have used Flask and SQLite for the database, so which will be serverless. So we have choose this one, and SQL Alchemy to connect the Python with SQL. Then for machine libraries, we have used Extreme Gradient Boosting, Scikit-learn, SBERT, FICE, and NetworkX. The NetworkX is used for extracting the graph-based data. Then for explainability and visualization, we used SHARP and Matplotlib for Matplotlib and Seaborn for visualization. And the utilities we have used are Pandas, NumPy, JobLib, OS, time, warnings, and sparse CY for mainly extracting the name in the resume, which is a name entity recognition. And PyMU PDF is especially used to extract the data that the candidate has uploaded as PDF. And Python doc to text is used for the candidate who have uploaded the resume in doc format. So our dataset is a publicly available dataset. So this dataset contains 4 labels. Label 0, 1, 10, and level. Label 0 is a legitimate LinkedIn profile, and label 1 is a fake LinkedIn profile. And label 10 is a ChatGPT generated legitimate LinkedIn profile, and label 11 is a ChatGPT generated fake profile. So it contains nearly 19 text columns and 17 numeric columns. And we have compared our models with the XGBoost models with other models like random forest, SPM, KNN, logistic regression, and decision tree. And finally, we found that XGBoost outperformed the other models. So we have compared it using the time and also the accuracy. And XGBoost took minimal time and achieved high accuracy. So the limitations that we faced in our project is that our model is fixed. That is, we have trained only once, so it cannot adapt to new fake profiles that they emerge. So there is a need for retraining, and also brittle resume parser. That is, we rely on specific keyword for extracting the resume. So it may be difficult if the candidate had used some other names for the same topic. Then the third limitation is the new user coaster. So if a candidate is new, or if he or she is the fresher, so he may have only zero or nearly a minimal number of followers. So it is difficult to classify it as a genuine or fake. And the future enhancement includes, that is already I said, we need a retraining and skill gap analysis. So we can compare the candidate resume and the job description of the HR to list the missing skills of the candidate so that they can improve their resume. And also we can recommend some courses for the candidate side so that they can enhance their resume well and can get hired. And finally, we already said our project is a keyword based parser, so that we can replace it with LLM based parser, which will be helpful for accurate extraction. So to conclude, we have developed a model which is used for fake profile reduction and also enhancing the candidate recommendation for the HR side. Thank you, ma'am.
Any questions, Melody ma'am?
Yes. Miss Shamela, what's
Yes,
the
ma'am.
size and composition of your data set when it
We
comes to
contain
authentic
nearly
and deceptive profile?
3,600 profiles, and we need to incorporate some more synthetic profiles for to detect it more accurately.
How were the text, numeric, and graph features selected and validated to ensure fake profile detection?
For graph-based features, we took workplace and education as a common thing, and we generate a graph for it using, and we calculate that we mainly take degree centrality and page rank for the graph-based features. No?
Okay, thank you.
Thank you.
Dr. Aneri, any questions?
Okay. First of all, what are the main challenges you are having whenever you are training this fake detection profile?
Sorry, ma'am. Could you please repeat the question?
Okay, I am asking that what are the main challenges you are getting whenever you are training this detection of fake profiles?
The main challenge is that even though they are a genuine profile, they may have some zero or nearly a small followers when they start as a fresher. So our project mainly focuses on followers and connections, so that it may detect it as a fake profile if they have low followers. So we face these as a main limitation now, and we are
Okay.
planning to
And
improve it.
okay, and how you are detecting the AI generated profiles? How you are bifurcating that?
Yes, ma'am. We are calculating a probability score using the pre-trained model. So initially, if it is greater than or equal to 0.5, we direct it as a fake profile, or else we assume it as a genuine profile.
And what is the scalability of your system if you want to go for the large platform or large data set?
For initially, it is okay, and we are we need to retrain it with some more synthetic profiles, which will be emerging now using some chat GPT generator, LLM generated profiles.
Okay. Okay, thank you.
Thank you.
Yes, thank you, ma'am. So next, I would like to call Hasti Badolia. Hasti Bhalodia, ma'am, or any of the co-authors of this paper present here.
Yes, ma'am.
Yes, ma'am. Please present your study on AR vein, augmented reality guided vein detection using NIR and UNET.
Okay. Uh, hello everyone. I am Hasti Balodia from the Charotar University of Science and Technology, CSPIT, in the Department of Artificial Intelligence and Machine Learning. Today I'm presenting AR vein, the augmented reality guided vein detection system using near infrared and UNET. And this research work is carried out under the mentorship of Dr. Neerav Bhatt, Dr. Hardik Jaiswal, Mr. Deep Menda, and Mr. Gaurukumar Gautam. So let me begin with a question. According to the WHO, did you know that 1 in 3 IV attempts are failed on the first try? And this rate in children can go high as I 54%. And already in pain, being a patient and imaging, we have to suffer the pain just to get a simple IV insertion. So, this can lead multiple needle insertions, increased pain and infection risk, longer procedure times in emergency situations. So, current commercial vein finders cost around 60,000 to 1.5 lakhs. That is limiting accessibility. So, our main goal is to build a low cost AI driven portable vein detection device that is easily accessible in emergency situation as well as in the rural areas. So, related work includes the near infrared imaging that lead the good contrast but sensitive to lighting and skin tone. Generally, darker skin tone have the problem with the NRI imaging, and classical methods, which has the poor generalization. Then deep learning along unit, accurate but rarely mobile optimized, and augmented reality systems that need the special hardware. So the research gap I have noticed that there is no end-to-end Android based systems that is integrating near infrared, UNET, and real time augmented reality in real time. So the proposed solution to solve this problem is AR Vein, a portable mobile-based vein detection framework that combines the near-infrared imaging, lightweight unit segmentation, augmented reality overlay that independently runs on the Android device and is a low-cost hardware under the 300 grams of weight using the Arduino Raspberry Pi and LED. So the methodology includes image acquisition. The first one is it is captured the near infrared imaging using the Arduino with LED illumination. Then the pre-processing will occur after filters for uh, contrast enhancement and noise reduction. The segmentation will occur that will use the UNet model to create binary vein mask. So currently we are basically this paper is the conceptual paper. So we are working on that and the first training is completed. So we have used the public data set of containing 1500 images and generated masks one by one manually. So we have the strong data set. After the segmentation, we have AR overlay, the project segmented veins onto skin in real time. After that, we have the mobile integration, deploy pipeline on Android, Raspberry Pi with user interface, testing and validation, evaluate performance across conditions and metrics, and at last the future enhancement that includes the integrate depth estimation and telemedicine support. So our algorithm includes the live. First, we will give input of the live near infrared frames from Arduchem. The output will be the AR overlay of veins on patient skin in real time. So initialize Arduchem and LED illumination. Then, while system is active, we have to capture the NRI image from camera, pre-process image. After that, apply histogram acquisition or using the CLAHC framework, apply noise reduction filters, feed pre-processed image into lightweight unit model, generate binary vein mask. After that, align the mask with real world coordinates using AR core and then overlay vein map on mobile display in real time. After that, allow user interaction for positioning and adjustment. And at the end, we have the overlay AR augmented reality vein on the patient skin in real time. So the expected outcome includes the accurate real-time vein localization, then reduced failed IV attempts, and works across skin tones and age groups, whether it is obesity, have patient, or affordable and portable, as I said earlier, suitable for rural clinics and emergency care also. So these are the top 10 references of basically I will read the 50 plus articles and research papers. So these are the top 10 references. Thank you.
Aneri ma'am, any questions?
Okay. First of all, my first question is that how you can get the verification or how you are identifying the variation in the skin tone.
Like ma'am, we are capturing the near infrared imaging using the Arduchem. So it will be the image of in grayscale. So it will be red and sorry, black and white images only, near infrared images.
Okay, and how can you improve the vein visibility?
So we are applying the pre-processing to the captured image. So it will enhance the contrast and reduce the noise.
And is there any, if there is an irregulation in the light condition, did your model will be act differently or there are some pros and cons in your system regarding the light condition?
Yes, ma'am. Initially, we have implemented the YOLO version 5. So there's a problem of the light condition at all. And in after the implementation of UNET, we are working on that, and I think there is no problem of the light condition in deep learning model.
Okay, thank you.
Thank you, ma'am.
Dr. Melody, do you have any questions?
Yes, I would like to know how does your ARV perform across different patient groups, say the obese, pediatric, elderly. How does your ARV perform to these patient groups?
Okay, so basically in near infrared imaging and using the AR vein. First of all, we are capturing the near infrared image and then pre-processing it. So in manually, there's a problem of skin tone and all, ma'am. in our system, there is no problem at all because we are capturing the image of the particular part where we where we want to intravenous access. So there is no problem of obesity or any
The
skin.
elderly, yeah, just like that.
Yes.
Okay. Have you tested this with healthcare professionals?
No, ma'am. Currently, we are working on that.
Okay.
The initial model was YOLO version
Mhm.
5 that we have tested, but the accuracy rate was the 83% only. So
Mhm.
then we have shifted to the deep
83%.
learning.
Okay.
Yes.
So it would be good if we can test this when the accuracy is raised to a certain percent higher than the 83%. No?
Yes, ma'am. Using deep learning, we can increase the
Yeah.
accuracy using the same data set. So we have shifted to the unit.
This is actually a very good research because it addresses uh, current trends in medical technology. No? All
Yes.
right. Congratulations.
Thank you, ma'am.
Yes, thank you, ma'am, for your presentation. Next up, I would like to call Amit Bikram Roy to present his study on machine vision-based extinct fish recognition, Bangladeshi freshwater care. Amit sir, are you present here?
Yes, I'm present. Am I audible?
Yes, sir.
Okay, can you see the screen?
Yes, sir, we can see it.
Okay. Good morning, everyone, respected chair and colleagues, and thank you for being here today. I'm Amit Bikram Roy from Independent University, Bangladesh, and today I'm presenting my work titled Machine Vision-Based Extinct Fish Recognition, Bangladeshi Freshwater Case. So Bangladesh is the home to incredible freshwater fish biodiversity, but many of our native species are declining fast because of overfishing, pollution, and habitat loss. So what worries us the most is that the endangered fish still appear in the local market and often misidentified. So it speeds up their extinction. So we believe that AI-based recognition can play a huge role in the conservation and monitoring and raising the awareness. So our goal in this work was to build a reliable deep learning system that can accurately identify these endangered fish even in real-world situation. So the main problem that we wanted to address was that manual fish identification is slow and heavily dependent on rare expert and also inconsistent, and sometimes also inaccurate in noisy market settings. So our research matters to us because it can help prevent accidental harvesting of endangered species, and also it promotes sustainable fisheries. So we targeted 6 species for this research. So we did 6 classes. It started Tarabaim, Deshi Magur, Kajoli, Kholisha, Deshi Koi, and Tangra. So they are very culturally and nutritionally significant for us, and also real indicators of ecosystem health. But many species are now rare due to market exploitation. So globally, there are some backgrounds. There are many studies on fish recognition using models like YOLO, ResNet, and hybrid CNN that has achieved around 90 to 95% accuracy, but it often used controlled data. But in Bangladesh, little work exists, but they use very small data set like 100 to 300 images per classes. So we saw a clear gap, and there was no large-scale study with real-world images of our endangered species. That's why we collected more than 805,000 data, and we collected images from markets and rivers across multiple districts to capture the real variations, different lightings, cluttered variation, multiple fishes in one photo, various orientations, etc. And we researched them into 224, and we also applied heavy augmentation. and created equally 1400 plus images per species. And we also evaluated with some pre-trained models like ResNet 50, VZ16, Inception, V3, and Efficient Net B0. And we also proposed a custom CNN model. So instead of relying on heavy pre-trained model, we also designed a custom light-well CNN, specially tailored to this fish morphology and the challenges of market images. So it has 6 convolutional layers with filters increasing from 32 to 22 to 56. And we also used ReLU activation, max pooling, dropout for regularization. And we finally ended with a dense layer with soft meta output. So for this custom CNN, we had to iterate around 5 models. So after 5 iteration of the tweaking the model, we achieved 97.42% accuracy finally. So if we compare with all the performance of all the models, we see that within the custom model, the custom model has achieved the highest accuracy, and pre-trained model achieved around 95 to 96% accuracy. And especially our custom model, when we look at the precision recall and F1 score, especially performance on challenging images with poor lighting and complex background, our custom CNN actually showed the best and the consistent result overall. So in conclusion, we have developed almost highly accurate, robust and lightweight system, the first of its kind using largest real-world dataset for endangered Bangladeshi freshwater fish. And for future work, we would plan to include more species, more class, and collect even more diverse images and deploy the model on mobile or web platform. So even fishermen, vendor, and conservationists can use it directly in the field. So we truly believe that it can help protect our aquatic heritage before it's too late. And thank you so much for your attention. And I'd like to take any question.
Dr. Aneri, any questions for him?
Thank you for the presentation. And there are any future extraction technique which you want to work and which will, as per your prediction, you are finding it is the best for this model?
I'm sorry, can you repeat the question?
I'm asking that you have worked on a different models or
Right.
different extraction technique. So in the future, you are thinking about to have an add-on other model, or you want to work on the model, or you want to improve the data set?
So
And you want to
mainly,
work on that.
ma'am, we would like to improve that data set because our data set is around 9,000 images right now. So if we can add more classes and more image, I believe that it will be able to identify the images more accurately. And we would also like to add more custom, more pre-trained model to check. And if we can, and I mean, we would try to develop maybe another custom model or improve upon it so it can be more accurate.
Okay, thank you.
Hello
Hello, ma'am.
to Amit, Mr. Amit. Yeah. You said here extinct fish. So I'm thinking that this fish has no living members left anymore. Extinct or endangered fish?
Mostly endangered, ma'am, and
Okay, so it's
some of
endangered
maybe
or very rare species, no?
yeah, actually, ma'am, it's
Yeah.
very rare and endangered. But for example, ma'am, Deshi
Yeah.
koi has some different varieties, and some of the varieties is already extinct, and some of them are still found. So that's why we use
That. Okay, so what I thought is nothing, nothing's left from that family. All right, for the in case, the system, how would you handle unseen fish species? For example, new species.
Ma'am, sorry, I didn't understand. Can you please?
How would the system handle a new or unseen fish species?
Okay, so ma'am, we we'll have to maybe run the whole model again. So when we will add the data set, so we'll use images, visible images from maybe camera or phone from the market, found from markets that captured by us. It's a custom data set. So after adding the data set, we will have to run the whole model again from the scratch.
All right. So endangered fish is the one that you're referring to, the extinct fish, right?
Right.
Okay. Thank you.
Thank you.
Yes, thank you, sir. Now, next, I would like to call Daryl Cardona for presenting a study on Mueller, a geospatial Internet of Things framework for cattle monitoring using point-in polygon processing.
Good afternoon. I am audible.
Yes, sir.
Okay. Is my PowerPoint visible already?
Yes, sir, we can see it.
Thank you. Okay. Okay, good afternoon, everyone. By the way, again, I'm Daryl Cardenia. Here's my research about MOLAR, a geospatial Internet of Things, or IoT, framework for cattle monitoring using point-in polygon processing. So livestock management in rural areas is challenging, especially for monitoring free-ranging cattle. Traditional methods such as physical fencing, manual herding are very labor-intensive, costly, and often ineffective. So this limitation may lead to losses due to straying, theft, or animal harm. So there is a growing demands for sustainable and efficient livestock monitoring technologies. IoT solutions shows promise, but many systems are expensive, excuse me, difficult to maintain, or lack real-time spatial awareness. So most of existing IoT-based livestock tracking system rely mainly on the basic GPS location tracking. So while GPS can show where the animal is, many systems do not use advanced geospatial algorithm that can accurately determine whether an animal is inside or outside the defined boundary. So only a few system applied methods, such as the point in polygon algorithm, which is important for handling irregular grazing areas. So in addition, so many IoT solutions require continuous internet connectivity or consume high power, making them impractical for the rural environments with limited infrastructure. So there's also a limited research focus on the developing low cost, open source, and locally adaptable livestock monitoring system. Because of this gap, there is a clear needed for a scalable and practical IoT solution designed specifically for the real-world resource constrained agricultural settings. So this study introduced a system called Molar, an IoT-based cattle collar designed with intelligent geofencing using point-in polygon algorithm. So this system uses a low-powered microcontroller to monitor cattle movement in real time through GPS and virtual boundaries. So when a cow exits, it defined the geofence areas. So the system automatically sends alert to the farmers, allowing immediate actions. The system is designed to be a non-intrusive and cost-effective, ensuring that it does not cause discomfort to the animal while remaining affordable for the farmers. So by utilizing open source hardware and geospatial algorithm, Molar improves the accessibility and makes the technology more suitable for rural environment. So IoT technology have significant improvement like livestock monitoring, particularly for free-ranging animals in the large grazing areas. So one of the earliest concepts supporting this development is the virtual fencing. So, which was introduced in 1987 and has since evolved into GPS and IoT-based system that help reduce the animal stress and improve grazing management. So today, wearable collars can provide real-time data on the cattle health, behavior, and productivity, making farm operations more efficient. However, while the basic GPS geofencing system exists, many struggles to handle irregular land shapes and depend heavily on stable internet or cloud connectivity. So advanced geospatial techniques such as the point in polygon algorithm enable more precise boundary detection, but they are still rarely applied in livestock tracking. Although low cost technology like Node MCU, LO Rowan, RFID GPS have made monitoring more accessible. So this a total of 30 participants were involved in the study, consisting of 10 agriculture instructors and 20 students. So the two cows, from the university's herd were equipped with Molar or the system, or the prototype to evaluate the system performance in a condition. No? So this sample size was sufficient for focused observation and detailed data collection. So in terms of the data collection, the study employed a mixed method approach, structured surveys and questionnaires based on the ISO 25010 quality model were used to assess system usability and reliability. So there's a field observation focused on the cattle behavior, grazing patterns, their interaction with the virtual geofence. Semi-structured interviews were also conducted. And then the main purpose of this is to provide a smart and low-cost livestock management solution. And it prevents cattle from straying through the use of GPS tracking and virtual boundaries, supports rotational grazing, and provides a real-time alert. It secures a web-based dashboard, allows continuous GPS data synchronization and monitoring. So in terms of system specification, the process model handles cow registration, geofence setup, movement logging, SMS alerts notification. Then the system services include cow registration, that IoT level data flow from the caller to the cloud server, then to the dashboard, and finally to the farmer. So the geofence setup interface allow users to create a visualized virtual boundaries using a polygon map. So ensuring the livestock stays within designated grazing area. So and also the real-time location map displays the geofence boundaries and live cow location within a green markers that indicates current position, and its select a mark shows a cow details such as names, breed, status, and GPS coordinates. So the system used an OpenStreetMap for interactive geographical visualization and monitoring. So the movement history interface enable tracking for cattle movement over time using daily, weekly, monthly, and yearly filters. So and also historical location are shown using cow icons, allowing analysis of movement patterns and detection of behavior outside the geofence. So in conclusion, the study developed a system called Molar, an IoT-enabled cattle collar with GPS tracking and virtual fence. So we use point in polygon geofencing accurately classified all GPS points, confirming reliable real-time boundary monitoring. Then the system provide effective for livestock tracking, asset monitoring, and security application. And then it has an average usability score for 4.5, no, which is usable, no, highly usable and reliability and efficient. Then a platform for real-time map and alerts were praised from the use of suggesting adding a mobile app and for future. And the overall evaluation confirmed that the system is functional, reliable, user-friendly, secure, and portable. So for future improvement, may enhance its interface aesthetics, accessibility features, and set. And also the prototype, it should be enhanced it also. Like, I think that's all for my presentation this afternoon. Thank you very much for listening.
Aneri ma'am, any questions for him?
Okay, you are basically working on the IoT system.
Pardon me.
So I'm just want to ask that you have taken any security measurement or a parameter into a consideration?
Actually, you just only use the parameter for the needs for point in polygon, which is the latitude and longitude.
Okay. And as per my opinion, if you are using the node MCO, it is my opinion, you can also switch for ESP32. I think it will give you the better results compared to your node MCU. And have you measure any cost criteria regarding your whole system?
I'm sorry, ma'am. We don't have cost detail.
Okay. So whenever you are thinking for a large scale modeling, then you have to also consider the battery parameter or a battery wastage or a noise. Along with that, you have to consider the final prototype cost so that
Okay.
you have the clear idea.
Okay. Thank you, ma'am.
Okay, thank you.
Yes, Melody ma'am, any questions?
Hi, yes. Hi, Darrell.
Hi, ma'am.
Yeah, you have a very timely research, no? It's practical and relevant in livestock management.
Yes, ma'am.
Okay. So how frequently does your system update livestock location?
Um,
Really?
Actually, yeah, we set that every 5 minutes.
Oh.
Mm-mm.
So how does your system perform in areas with poor internet connectivity?
Actually, we used to. So, in our school, our cows are or our cattles are raised in because our school is an agricultural school.
Okay.
We have a lot of cattles there, and then we we asked two cattles only for this for this study. So our campus is an smart campus, so there's a lot of internet, but we also put a what do you call this one, a for texting. So if
Mm.
there's no an internet, so they just send messages.
In the evaluation, did you consider the end users, the farmers?
Yes, ma'am.
Okay.
Mm-mm.
Yeah. Okay. Congratulations.
Thank you, ma'am.
Yeah.
Yes, thank you, sir, for your presentation.
Thank you.
Now, next, I would like to call Kavya V to present her study on prompted and prejudiced reviewing bias in LLMs for natural language generation. Kavya ma'am, are you present? Kavya or any other co-authors of this paper? Okay, Rachel John Robinson. Rachel ma'am?
Yes, I'm here.
Yes ma'am, please present your paper on threat analysis of insider threats for organizational security.
Yes. I hope my screen is visible.
Yes ma'am.
Thank you. Hello, everyone. I welcome you to the International Conference on Machine and Computing Technologies. I'm Dr. Rachel John Robinson, a researcher based in Chennai, and I'm here to present the paper titled Threat Analysis of Insider
Excuse
Threats
me
for
ma'am.
Organizational Security. Let's get started. Yeah.
Your voice is unstable.
Okay. Here is the agenda for the discussion. Is it okay?
It is coming at quite a fast speed. I don't know.
Moment. tropical continents, Asia, adopt new technologies. Is that okay?
Yes, ma'am.
An alarming level of cybersecurity risk appear due to lack of strong infrastructure protection mechanisms and a work culture that do not enable strict security measures. One does not need to be surprised over the situation because of the lack of proper controls on these threats means that there is little or no progress made over time. Due to the poor progress, most researchers have concentrated on developed countries which regulated inadequate research on how these insider threats affect the organization and the internal control procedures in emerging markets. In addition, organizations fail to understand the interplay between psychological, social, and organizational aspects leading to insider threats. The presence of adaptive security measures like user and entity
Ma'am, your voice is coming
analytics,
too
UVE,
fast.
and ZTA, zero trust architecture. Promise are to identify and address pre-embraced insider threats, but they do not provide an ultimate solution. Okay.
Yes, ma'am.
Yeah. This paper seeks to investigate how the impact of insider threats have influenced the state of organizational security in emerging economies today. In the intent to analyze the existing security measures and identify the regional challenges in order to recommend consolidated approach that incorporates technology-based securities together with people-centered security systems. Such a problem has and will be seen in this paper with practical solutions aimed to enhance organizational resilience in preventing insider threats. The paper aims to measure the insider threats that affect security systems used by the companies in emerging economies. In relation to it, the identified objectives are seen as below. To examine the various types of insider threats present in the organizations. Next, to evaluate how insider threats influence the overall security measures and operational integrity of organizations. Next, to investigate the effectiveness of existing insider strategies in minimizing insider threats, and so as to propose recommendations for enhancing organizational cybersecurity resilience against insider threats. This review outlines how the insider threats occur, such as psychological, social, and organizational factors that motivate the insiders to perform such actions in varied organizational settings. As an extension to this, setting the literature base via all the information in the below topics has been used in this work, including the related work paper findings, data, and summary. And likewise, of course, these topics have not been only rendering to the research, but also to the rest of the resources have been cited and referenced accordingly throughout the work. One of the first areas identified as part of the detailed literature study is insider threat landscape. These insider threats are not only the major concerns of cybersecurity, they refer to unauthorized use of authorized access by individuals within the organization. These individuals deliberately and inadvertently compromise the integrity, confidentiality, and availability of the organization data and systems. Unlike external threats, insiders enjoy authorized access, and their actions and activities are not only easily detectable or preventable through traditional security measures. Insider threats can be divided into two major areas like malicious insiders and unintentional insiders. Then coming in terms of the distinction between insider and external threats, perhaps the biggest difference between these two is the access and privileges. Insiders have authorized access to the systems and the data of the organization, which they use to maliciously or accidentally cause security breaches while performing their jobs. External attackers must first breach the organizational defensive walls, firewalls, and intrusion detection systems before they can have unauthorized access. They say that inherent access allows insiders to bypass traditional security measures put in place to protect against external threats. Finally, in terms of the organizational security structural factors, purely designed security policies can sometimes have an unintended consequence of encouraging employees to work around security policies and create insider threats. For example, strict password policies or heavy access controls will employees or drive the employees to find ways to make their lives easier, such as password sharing or using weak credentials to make their jobs easier. These risks can be mitigated by organizations that balances security and operational efficiency. Role-based access controls or RABAC and adaptive access management can help create employment access only to what they need to do with their job and reduce the attack surface and the insider threat rate. Discussing in the gaps identified, despite all literature of threats, there are many areas have been covered, especially the dynamic insider threats in developing market, new technology. Most of what has been focused on regions, North America, Europe, industries where security is concentrated in finance, healthcare, and technological. But areas like Africa, Southeast Asia, and Latin America, where the security infrastructure is still undeveloped, have been little neglected. Technical imbalance resulted in research addressing the unique challenges faced by organizations in these on threats. Organizations in developing markets face more situations, lack of resources, and prior experience in cybersecurity and insider threat area. This is worsened by the absence of effective cybersecurity frameworks and legal systems. There is lack of contact studies on how local regulation and economic conditions affect the threats in the areas. As organizations in these areas adopt digital technologies and interconnect systems like and cloud mechanisms, the risk of cyber threats only grow.
Yeah, in terms of the statistics, the cleaning of the data is then done along with it. The inferences are framed finally to from the triangulation of the data has been dealt in terms so that resources are properly and attuned to the needs of the data set that has been gathered. The operative tools for analysis have been Quadas and Atlas TI have been used to incorporate the visualizations, etc. The key interview interprets of the research have been divided into the thematic areas. First of all, to identify the psychological factors, and then of which the detailed interpretation has been framed out of which where the driving individual consumer motivations have been identified to form the nature of the data theft mechanisms, and the system sabotage methodologies were also detailed enough. Following which the comparative analysis making a coercion between the data set that's been available on the psychological factors that's been interviewed along with the malicious attacks that's been recorded have been commented. Finally, the practical implementations leveling up to the level of awareness needed for security protocols within the organizations have been set up as a base for the overall research output. Research output in terms of the discussions. Here in terms of the first infographic, we see the insider threat survey exhibited around 74% of the threats were recorded in the last 12 months, of which malicious insiders threats were around 59 to 60%, and financial management and data theft have been the next high operated areas when it comes to cyber threats. Here in terms of the infrastructure, it has been identified sector-wise, people who say they have enough infrastructure and they don't have enough infrastructure to support the cybersec activities have been recorded. This is trying to implement and show it out that the limited infrastructure of maybe around 32 or 51 respondents, around 67%, saying that's a great limitation of a limited infrastructure. This is highly also seen in the financial sectors of 40% and in healthcare sectors of around 55%. So this is a major gap that's been recorded and critically to be acclaimed of when looking out for the next levels of implementation of security protocols.
Excuse me, ma'am. Gentle reminder that you've crossed 10 minutes.
Yeah, thanks. So in terms of the results and discussions, so the final set of results and discussions were correlated with a heat map to identify where is the real correlation, which has been identified in terms of the infrastructure lackness. along with the different side of cybersec exposures that's been implemented or identified across sectors were correlated, and so was the results as you see in the graphical representation here. So one of the major areas that's been identified was the mitigation plans of bringing in the complex device mechanisms like BIOD and today AI-driven technologies, taking the charts of the organization multifaceted approaches. So in all these realms, how does this heat map variant to their behaviors of the new technologies and complex infra situations inside the organizations? So multifaceted approach were implemented or required, so to say, along with proactive nature of threat detection and vulnerability management with ongoing trainings is highly demanded and recommended for the organizations. Also, timely audits, security audits, and a good span of time for enhanced security will help in more greater approach of security landscape inside the organizations. So that being said, the future scope has also been titled here in various categories, like what could be the security strategies that management could think about, what could be the evaluating mechanisms, like what could be the performance mechanisms that organizations can think about when talking about security implementation. Do they have enough performance metrics and yardsticks to measure that? Talking about interdisciplinary approaches like co-betting with other organizations, peer influences, all these things could also be deepened out. Also, this could also be a good breeding ground for future researchers when it comes to fostering enabled security mechanisms inside the organizations. So this being identified as the future scope of the particular topic, I guess the topic by itself is a breeding ground for more in-depth work in future in terms of insider threats. So that being said, the references for the research have been given here, and thank you for your time and listening. I'll be happy to connect and open for questions.
Melody ma'am, any questions for her?
Yes. Ano pa ba? What regions or countries are included under the term
Sorry,
tropical
ma'am, your
Rachel?
voice was cut. Can you come again?
Okay. I'd like to know what region or countries included in your term tropical continents.
So the tropical continents included the South Asian countries as well as countries of, not all countries, but some countries from Africa as well. So not 100% of South Asian countries or Africa has been covered. Representative nature, around 15 countries were covered containing these two continents.
Okay. So how did you operationally define malicious and unintentional insider behaviors?
So the major data source were the security practitioners or analysts. They were the target audiences of this research. Through the empirical study, we happened to talk with the security representatives of these organizations from the different countries, and their inputs and their insights about what type of threats they had experienced in the past. So those have been collated enough to form the base of the research.
Okay, thank you.
Yeah.
Aneri ma'am, any questions?
Okay, what are the significant challenges you are getting whenever you are analyzing this thread processing?
It's very dynamic. It's one of the first challenge because every day technology changes, and yesterday's challenge is not today's challenge anymore. So that is one of the biggest, so to say, challenges in the security realm. It's very dynamic. So maybe the insider threats, since it has to do with humans, human being a major part of organizational operations, right from the start till today, also in future. So I guess insider threats is one of those areas which still happen to be a live threat for in terms of cyber threats. But apart from that, the operational or the mission-led challenges are quite dynamic and keeps on changing. So we got to update it and keep on thriving for the new elements, so as to understand how these challenges could be relevant enough for study in future.
Okay, thank you.
Yes, thank you so much, ma'am.
I thank you. I thank you all for the presentation, patience on listening to my presentation, and for the good questions. Thank you so much.
Julius A. Sereno. Julius, sir, please present your study on use of artificial intelligence for enhanced administrative efficiency and strategic decision architectures within the higher education ecosystem.
Okay, good afternoon. Can you see my screen now?
Yes, sir.
So, good afternoon. I'm Julius A. Sereno from the Technological University of the Philippines, and thank you for this opportunity to present this research, use of AI for enhanced administrative efficacy and strategic decision architectures within the higher education ecosystem. So this study explores the transformative impact of AI on administrative functions and strategic decision making within higher education. Okay, the advent of AI has led to a transformative change in the way organizations function, and higher education is not an exception to this trend. AI has moved from speculation to reality, reshaping how institutions deliver services, manage resources, and make strategic decisions. From chatbots to predictive algorithms, AI is crucial for survival in a competitive educational landscape. So for global AI adaptation in education, uh, at any for the global spending on AI-enabled education technology reached 8.4 billion in 2023. US retention US retention, Georgia State University increased freshman retention by 5% using predictive models. And for European efficiency, European universities reduced paperwork and boosted efficiency with AI administrative tools. So for AI in Asian higher education, investment. Countries like China, South Korea, and Singapore heavily invest in AI for university operations. Also, China initiated an AI curriculum across 100 universities to automate administration. And India's national education policy emphasizes AI, piloting AI-based course allocation. In the Philippines, higher education, AI integration in the Philippines is still developing with a focus on instructional applications rather than administrative or strategic ones. For the growing interest in AI, but many institutions lack infrastructure and trained personnel. Pilot programs, some universities are testing AI-powered learning platforms and enrollment tools. And for campus operations, efforts are directed towards smart campus operations, including AI-powered feedback system. For the objectives, this research sought to identify and analyze the types of AI technologies utilized within the higher education ecosystem. It specifically it investigated the adoption and application of AI-powered tools such as chatbots and virtual assistants, predictive analytics and forecasting systems, intelligent document management solutions, robotic process automation, and AI-based student advising platforms. The investigation also looked at the infusion of machine learning algorithms for enrollment and retention, natural language processing for tasks such as automated grading and sentiment analysis, improvements in AI-driven LMS, biometric systems, including facial recognition for access and security, and tools for plagiarism detection, and the advancement of academic integrity. The investigation further sought to establish the efficiency level of AI and enhancing administrative efficacy within higher education. Three dimensions of administrative performance were assessed: workflow automation, efficiency in executing tasks, and reduction in manual processing errors. Other aspects that were evaluated includes system responsiveness to queries by students and staff, improved turnaround times of administrative services, and effectiveness in communication and notification. Other areas includes the cost effectiveness of AI deployment, integration of AI with existing management systems, efficiency in document and record processing, workload management among staff, and the quality of administrative support and reporting. So the descriptive quantitative studies investigated AI's impact on administrative efficacy and strategic decision-making in higher education. Data from 67 respondents were gathered through a 5-point Likert scale survey. So AI adoption in higher education at Technology Organization Environment Framework by Tornatsky and Pilsker, a robust model explaining how institutions integrate technological innovations like artificial intelligence. So you have here technology context, organizational context, and environmental context. For the technology context, it focuses on the characteristics of AI tools such as machine learning, natural language processing, predictive analytics, biometric authentication, and intelligent automation. These features dictate adoption based on usefulness, compatibility, and inherent complexity. For the organizational context, examines how institutional structures, workflow demands, staff readiness, resource availability, and current management systems influence successful AI implementation, directly impacting administrative efficacy. For the environmental context, addresses external factors like regulatory mandates, competitive pressures, accreditation requirements, and stakeholders' expectations, which compel higher education institutions to adopt AI for strategic planning and service delivery. By integrating these three dimensions, the TOE framework offers extensive theoretical lens to understand not just AI adoption in higher education, but also its profound impact on administrative operations and strategic decision-making process. So these are the results of the survey. So AI tools in use is always used. So these findings are supported by the Global Education Market Report. So AI tools are consistently applied across institutions with an overall mean of 4.31. It's always used. Which identified AI-powered chatbots, plagiarism detection systems, and predictive analytics tools as some of the most adopted AI applications within universities worldwide. Their research underlined the increasing use of AI in managing interactions, reducing administrative tasks, and upholding academic integrity. The next is AI enhances administrative efficacy. So AI significantly enhances administrative functions with an overall mean of 4.59 to a very great extent. So this includes workflow automation and task efficiency, reduction of manual errors in processes, responsiveness to student and staff inquiries, turnaround time for administrative services, communication and notification system, cost effectiveness in administrative operations, integration of AI tools with existing management systems, document processing and record keeping efficiency, staff workload management and redistribution, and administrative decision support and reporting accuracy. So AI supports strategic decision architectures. AI substantially supports strategic decision architectures with an overall mean of 4.56 to a very great extent. So these are the following as shown in the screen, and these findings agree with Williamson and Elinon, who stated that AI-based administrative systems have dramatically changed how tasks are executed in higher learning institutions, especially regarding automated enrollment, handling of records, and delivery of services to students and faculty. The study observed that such automation enhances not only speed and accuracy, but also reduces cost within the institution. For the-
Excuse me, sir. Gentle reminder that you've crossed your 10 minutes.
Okay, so for the conclusion, uh, we have here the result. AI is a key driver in transforming higher education, enhancing administrative efficacy and strategic decision making. It's not just an operational tool, but a strategic enabler for agility, efficiency, and data-driven governance. So with this, we have to go into the continued investment in AI capabilities, professional development for AI integration, and robust ethical policy frameworks. And thank you for your kind attention.
Melody, ma'am, any questions?
Hello, Sir Julius.
Good afternoon, ma'am.
Good afternoon. Um, how representative is your sample of the broader higher education ecosystem?
Actually, I have, thank you, ma'am. I have selected institutions in the National Capital Region using, particularly using those AI-powered systems. So that was 67.
Okay. So which AI tools had the strongest impact on the strategic decision making?
So for the highest, actually, we have the AI tools that often uses the chatbots and plagiarism detection systems attributed to the immediate and tangible benefits and addressing pressing needs within higher education institutions, ma'am.
Okay. So
And
that
for
would go
the ano ma'am, for the lower rating,
Yeah.
integrating AI tools with existing management systems often present significant challenges due to issues of compatibility, data silos, and legacy infrastructure, aside from the resistance coming from the people.
Okay. Thank you.
Thank you, ma'am.
Anidi, ma'am, any questions?
Hello.
Good afternoon, ma'am.
Good afternoon. Your model will handle the inconsistent academic data. You have worked on that?
Document data, ma'am.
Okay. And your system is adaptable in any system across any institution or anywhere?
Yes, ma'am. Actually, AI played a crucial role in the strategic decision making, specifically in Philippine higher education institutions, particularly in crisis management and policy formulation, uh, even in data-driven insights. But considering the ethical implications of AI in education, it requires a multifaceted approach that prioritizes fairness, transparency, and accountability. So, uh, accountability mechanisms such as human oversight and appeals processes should be in place to address concerns and ensure that AI systems are used responsibly. By implementing these measures, ma'am, any higher education institution can harness the benefits of AI while upholding the ethical principles and fostering trust in AI-driven processes.
Okay, thank you.
Thank you, ma'am.
Thank you so much. Now, next, I would like to call Sagar Mekala to present a study on a blockchain-based cryptographic framework for secure authentication and authorization in session management systems. Sagar sir?
Good afternoon, madam. I am sharing.
Yes.
Is this visible, madam?
Yes, sir, we can see your screen.
Yeah. Good afternoon, madam, session chair, and my dear colleagues. So this is Sagar from CVR College of Engineering, Hyderabad, India. So here I'm going to discuss my presentation on blockchain-based cryptography framework for secure authentication and authorization in session management. So here are my just before going to the what we are going to consider in this particular presentation, I try to introduce my problem, then followed by the literature survey. Then I try to explore the proposed model for the authentication and authorization. Then we discuss about the results based on my proposed model, and I finally I conclude the my presentation, and then. Coming to the my problem, that is a, it is in a novel cryptography framework using blockchain technology to improve the authentication and authorization in session management. So basically, the traditional web applications based on the HTTP and HTTPS protocols for client-server communication using session based that session abstraction based on the cookies to maintain the user authentication as well as the authorization. So, sir, yeah, session management systems are vulnerable to various security threats, including brute force attack and phishing and traditional theft. So, basically, we are going to use these applications on cryptocurrencies, supply chain management, smart contracts, voting system, healthcare systems, financial and banking, digital identity verification, real estate, and other various applications. So, in these application areas, we have major challenges. So, that challenges we are going to consider, that is HTTP protocols for the client and server communication. Uh, Based on the cookie representation that leads to various cryptography attacks like brute force attacks, phishing, and then we have to consider. So then, in order to address these problems, we are going to propose a novel cryptography framework integrated with blockchain technology in session management, so that uh, we can able to uh, perform various public key, private key cryptography for the authentication, and it enhance the efficiency of the system. And the smart contract based authorization rules are imposed to perform the authorization authentication in the session based management systems. And this particular model is immutable representation, where that particular user and user credentials are logged, and they may not be changed in the further processing, and a decentralized identity management representation. So then so based on this in this particular area, we have some other related literature review. Already we uh, there is some huge literature on this particular authorization authentication in application, whatever the application I given in the previous slide, so that to address these issues, so most of the research is based on the cryptography algorithms. So then a cryptography algorithm. So then uh, here I consider my model with the blockchain the traditional cryptography algorithms with the uh, blockchain technology to enhance that particular process, that is authentication and authorization. How we are going to address these issues? Just we need to consider, and these are the objectives in the paper I'm going to consider. This is a new integration for the authentication and authorization in the session management, and develop distributed identity management using public private key cryptography. And then we implement a smart contract based authorization and immutable session blockchain for the tamper proof authentication records. So we evaluate the proposed framework effectiveness by using the security compared session management system. Sorry for the interruption. Just getting some noise. So, in my architecture consisting of various important components, that is client, app server, the blockchain based implementation, and smart contract. So, with this components, we are going to achieve that decentralized identity and authentication and authorization with the help of the blockchain in the session management representation. We can't change that particular user and or the user credentials in the session management presentation, and it is addresses that blockchain latency with configurable interactive apps. And then this is a basic algorithm we are going to consider for the authentication and authorization in session management. That is with that algorithm is with a cryptography and blockchain based representation. And then it is in a three-way authentication which combines the symmetric encryption for the data and asymmetric encryption for the key, and followed by the blockchain verification for the identity. So that here in the traditional approaches, we may use the symmetric encryptions for the data, or asymmetric encryption for the key representation. But we use these traditional approaches in the session management, so that the whatever the limitations in the traditional approaches will be eliminated, and the efficiency of the system, the authorization and authentication will be enhanced. So that is this process is suggested as first there are some sequence of steps, that is encrypt the session, request the data and the blockchain process, and store the encryption, uh, verification, and verify the identity, validity, authorization of a particular user, and submit the verified data to the application server, so that that data can be maintained for the user authorization as well as the authentication in the session management. And these are the some uh, results based on my uh, framework, and I compared that particular results with other research representation. Then the most of the results are based on the traditional approaches, traditional cryptography approaches. Here I'm going to consider that encryption will my blockchain based authentication and authorization will more efficient than the other traditional approaches. So then, coming to the conclusion, that is the key contributions in this particular framework is a decentralized identity, the smart contract authorization, and the phishing resistance, and the performance is more significantly better than the proposed that parallel research in the uh, session management representation. So then there will be some future scope, that is optimization blockchain techniques for the uh, high high-end application, web applications, and then we need to integrate hardware security models with the key management, and we can able to explore the zero. Then we conduct extensive penetration testing for the emerging attack vectors. So, and my final conclusion about this particular framework is how we are achieved that particular uh, objectives. That objectives are the decentralized identity, password elimination, of phishing resistance, and then if it is a decentralized, then we use public private key cryptography implementation and the password elimination, no password transmitted or the stored in the particular session, and then the phishing resistance, a private key never communicate. So that we can achieve our goal, that is authentication and authorization with blockchain integration in cryptography techniques. So these are the some most recently trends in the uh, session management system of authorization and authentication in session management system without blockchain techniques. And thank you all, and let me know any.
Yes, Melody ma'am, any questions?
What are the limitations of the proposed blockchain-based session management system?
Yeah,
Hello? Yes. So what are the limitations of the proposed blockchain-based session management system?
so here we consider that is we tested our model with limited uh, data sources, like limited user representation. If it is in the heavy load, then how we are going to perform our session that authentication and authorization with blockchain integration, we need to test it. So then we consider only the limited users representation, then we achieve the good representation or the significant results over cryptography models. But if the scalability, if the number of users or the number of authorized persons are increasing in the system, then how our model is going to be respond. That things we need to test. We need to test that we consider as a future work.
Okay. Okay. Thank you.
Thank you, ma'am.
Aneri ma'am, any questions for sir?
Good morning, sir.
Good morning.
How you can improve the security in your session management or any parameter you want to change so that your system will be more related or it will be improved?
Yeah, yes, madam. The traditional approach is that user credentials will be stored in the local storage or the global repositories, so that there will be some chances of phishing and chances of brute force attacks. So that we, along with that traditional approaches, we are going to consider the blockchain model, so that uh, so this kind of phishing and brute force attacks are going to be reduced. So
Mm. Okay, I will get it.
thank you, madam.
Thank you, sir.
Thank you, madam.
Now, lastly, we have Swati Rastogi presenting a study on smart animal forensics, footprint identification analysis using YOLO V8.
Good morning, all. Thank you so much for giving me an opportunity to present my paper. So let me share my paper with you. I hope the screen is visible.
Yes, ma'am.
Okay. Okay, so is this in full screen mode visible to all?
Yes, ma'am, your presentation screen is visible to us.
Sure, sure. Thank you so much. So, I'm Swati Rastogi, and I will be presenting my work on smart analytics. And within this, I will be doing the footprint identification analysis using our YOLO version 8. So, first of all, I will present my problem statement, what problem I have worked on, then the challenges and the application, what methodology. Basically, the methodology is worked in the two phases that I will present, and the results and the conclusion part. So the very first problem is that with smart animal forensic, why actually I chose this area? I'm already into biometric, intensive biometric, already working on it. But I chose to move forward because I was already with the human part, the human vein biometric I've already worked on. And I now want to expand my area up to animals. So for animals, it's actually very, very, very challenging when it comes to animal. Apart from humans, with humans, it is actually easy. The intrinsic biometric is easy because we know, we understand the things, we speak with each other. But with animals, it's literally difficult. So I will tell how I have extracted the data and how well YOLO 8 has worked with it. And the next problem statement was the learning models that I am using, how well they are performing with the forensic applications. Basically, why the forensic area? Because whenever we go with the animals, with the good animals, for example, rhinoceros or the deer, there is like lot of poaching of these animals for some or the other reasons. And in that reasons, because of these poaching things, and somewhere these animals are harmed intentionally. So in order to protect that, in order to have our animals being protected by these unhuman kind of things, so this is the forensic part that I have actually proposed. So moving forward, so these are the research gap. There are like many, the field is new, animal forensic is a new field, not actually very new field, but in some decade, last decade, it has been worked on. It lacks a reliable algorithm, and the linkage has been unexplored when we work on, when we talk about the animal forensic. Next is that the traditional methods are available, but they are not so handy and not so very good when it comes to the animal and footprint analysis. So basically, we can say there is a lack of comprehensiveness, lack of good exploration and the algorithms. So I have tried to work on these research gap and came up with the objective of being involved with these high-end learning models so that I can increase the accuracy of the footprint analysis. Not only analysis is one thing, but we have to match that footprint with the actual animal, because there are many footprints that match with, for example, if I talk about the rodents, rats, or lizards, somewhere they have the similar footprints. So it actually becomes one of the challenges when we work on this high accuracy part. So we have to work like, if it is a rodent, our machine or our model should be able to identify the correct identification of which animal footprint is this. So I have tried to work on this. Next is that with these learning models, the feature visibility of these prints, I have also tried to work on. Next is that key, I have also tried keep prediction accuracy is high, apart from being matching and predicting the things using the machine learning models. And then this proposed framework, and I have tried to increase the similarity score as much as possible, but it was not that too much. When I compared with the state of the art with the previous literature, yes, our model is performing very well. So, since our previous literature, the animal forensic is one of the very small part which people have ignored, or they are not interested to work. But somewhere I feel ki, we have to preserve our animal species who are in the extinction or who are being poached intentionally for some or the other reasons. So this is one of the reasons I have taken this field, because I'm already into biometric and the forensic field. I have expanded my field up to animals. So I will address the limitation, the traditional limitation, and I will also try to explore the learning models deeply, so how well the model is performing when it comes to forensic footprint or footprint of the animals, or we can say a wildlife monitoring. So basically, when I come to the methodology, so I have taken 9 classes here. There are many other animals also, but in this for this study, I have taken only 9 animals. The data augmentation is done, and the second part is that the training and the evaluation. So I have taken two models. I have taken only YOLO and all the version of YOLO, since this is the starting of the work. So I have taken YOLO, and I'm still into the consideration of various models. Which model will work well? Which model has what type of limitation? What model is good and has less computational time, will have high accuracies? So this work is still into the experimentation part. Or so, for example, I have taken the horse footprint. These are the footprints of horses, and you can say you can see that like it is actually difficult to capture these images and then to save it. And we have to do various field work. We have a team which go into the field, take these images, and then various type of pre-processing is done. So this is the horse foot. In horse foot, we can see the condition, the picture of horse foot in mud is different, at seashore is different. And when it comes to the stone part, in stone it is actually very difficult to capture the footprint. When there is a mud, when there is a wet mud, or there is a solid mud, so all such kind of conditions we have considered, and we have taken like multiple images, then pre-processed. So we were able to capture like this is the images that I am showing. This is already the database that is available, and this is a copyright data, and we have the permission for to use this data. Apart from this, we are also, I have a team of my own people who are working on the actual footprints in the condition right now. And we have like working on this for around like 5-6 months with various climatic conditions, so that we are able to capture the footprints in numerous conditions. So this is just the horse footprint. And apart from this, there are multiple images of various other animals too. Coming on to the result, when we have experiment all these footprints, and we have worked with the YOLO model, so we come up with the accuracy. So this is like 9 types of animals we have taken over: deer, chicken, duck, horse, then rabbit, rat, squirrel, tiger, and fawn. The data was already available, and we have different images. Like if for deer we were having 50 images, for chicken there were like 100 images, for duck there were like almost 150 images. So there are total number of images per classification is different, but in the using our model we were able to capture a good accuracy, or the good classification was obtained. As we can see, the true positive and true negatives are already reflecting in the confusion matrix. So our model, that was YOLO 8, I am working on. And with this experiment, we have actually tested various models of YOLO only. We have not worked on any other model. The experiment is still under consideration, and we are still working on it. The next part is the performance. The performance of YOLO 5, I have also considered YOLO 7. So YOLO 5, 7, and 8 I have considered. In our next experiment that is actually going on is with the YOLO 11 right now. So we are the results I don't have, but that's the future work where that is still going on. So we can say YOLO 8 performance, that is the green bar. We see the YOLO 8 has performed every classification of the animals that we are doing with the 9 classes over here, and the dataset is already available. So this is the matrix, that is MAP, that is highest accuracy we have obtained for the YOLO 8, and we can see for all classes for YOLO 8 we have got 0.86, that is 86% of the accuracy, that is the highest accuracy we have got. And when we consider about the past literatures, this is the maximum accuracy which we are worked on with our YOLO model. And once we see YOLO 5, we see it's a 0.78, that is 78%. And yes, but there are various other conditions, like there I have taken 9 classes of the animals. So for each and every animal, for each and every classes, we have different accuracies for YOLO 8, version 8, and version 5. So overall, we can see that YOLO version 8 has performed best with this model with our 9 classes. We have various other classes also, but it is still we are working on that. It is taking time. So in conclusion, I can say that with our evaluation matrices, I can say that YOLO 8 has performed well and has given the consistent performance across when we see the scores. And with the feature extraction, it has given a good performance with feature extraction, with spatial alignment, and the prediction accuracy is also good for YOLO 8. It is just
Swati
the
ma'am, gentle reminder that you've crossed 10 minutes.
Okay, sure. I'm about to finish. So, with this model, we have seen that YOLO 8 has performed well with 9 classes with our smart animal forensics. Thank you so much.
Aneri ma'am, any questions?
Yes. You have worked on the different YOLO models. So, what are the
Yes.
future models on which you want to work on?
Actually, ma'am, right now I'm just focusing on the YOLO 11 is the latest that we are still working on. It is in the experimentation part. That result we have not got yet, so I have not included here.
And what about your data set? How
So
your
dataset,
image?
ma'am, the dataset that I have used over here, as I showed this. This is the horse foot. So this dataset is already available. We have got the copyright permission from the owner of this dataset. Apart from this dataset, we are also constructing our own dataset, and the team is already working for past 6 months. So we have only few dataset available because, ma'am, the condition is different. In some climate, we get the footprint, and the people have to roam here and there inside the forest. So actually, it's a difficult part, but we are still into the condition. So by after a year, we will be able to complete the set of the data that we are working on. So for summers, the data is being collected. For the rainy season, people are still working on, and now the winters. It is winters over here. So in winters also, people are going. Our team of students are there in the there's a forest of this Uttarakhand. So they are there, and let's see what we will get.
Okay.
Because man, sometimes
Okay.
what happen, if I have, for example, this is horse foot. So we are
Hmm.
easily we this is easily identifiable. We can see this is a horse foot. But
Yes.
what if it is a deer? So we know with our deer species, there are almost like 12 to 15 types of deer species. And with every deer species, there is very, very, very minute differences in their footprints.
Yes, exactly.
So for that, for example, if I talk about the deer, so for we have 12 species in deer, and for all the 12 species, it is actually we are collecting the data so that our model and not this model is actually available. But we are also trying to build our own model that will identify, yes, this is the B type of deer or this is the D type of deer with the footprint analysis. So currently we are just working on that. So let's see how far we can go with it.
Okay. All the best.
Yeah, thank you so much. So,
Melody ma'am, any questions for her?
I'm sorry.
Yes. How much did YOLO 8 improve compared to YOLO 5?
How much, ma'am? What? How much?
Yeah. Have you compared?
Yes, ma'am. This is the comparison. See, this is the comparison of the highest accuracy of YOLO version 8. So this is only the 9 classes that I have considered over here, and the 86% of the accuracy I'm getting with YOLO version 8. If you want to see YOLO version 7, this is the YOLO version 7, but I have to calculate because I'm not
Mm-mm.
calculated here. It's here.
Okay. Thank you.
Thank you. So, Melody ma'am and Aneri ma'am, like, do
Yes.
you have suggestions for me so that what any other changes that I can do or I can consider in my work?
Yes.
Yes, you can work on a different model, and as per my opinion, you have to work on your data set.
That is
So that you are working on. Yes. So we
ma'am,
have already discussed that.
will take
So
time.
you can improve your data set. At the same time, you can add on the models so that you are reaching to the highest accuracy.
Yes. Yeah.
Mm-mm.
Okay.
Work on your data. Okay, thank you.
Thank you so much.
Yes, thank you ma'am.
Can I stop sharing?
Yes, ma'am. So with this, we have reached the end of the session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. We, on behalf of the whole team, thank you for the support during this version of the conference, and will be happy to have you in the next version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months, so kindly cooperate with the team of MCT4SD 2025. I would also like to thank our session chair, Dr. Melody De Vera, for chairing our session. Thank you, ma'am. I'm sharing a token of appreciation on behalf of the team and would request you to share any concluding remark for the presenters.
Yes, thank you very much, Ms. Dema Patel. Thank you, everyone, for your active participation in today's session. We extend our sincere appreciation to all the presenters for generously sharing their research findings and innovative ideas. Your work has contributed significantly to our collective understanding and provided directions for both practice and future research. As we move forward, let us continue to support one another and strengthen collaboration in advancing knowledge within our respective fields. So, on behalf of the organizing committee, we wish everyone a productive continuation of the conference event. To our participants in the Philippines, we also extend our warmest greetings for the upcoming holidays. Thank you very much. God bless everyone.
Yes, thank you, ma'am. I also extend a heartfelt thank you to Dr. Aneri Kilol Pandya for her valuable presence as our session chair. Thank you, Aneri ma'am. I'm extending a token of gratitude on behalf of the team and would request you to share a few words.
Okay, thank you. First of all, I am thanking the organizing team, MCT4SD 2025, for inviting me as in session chair. And I'm truly honored to be a part of this event. Here we have a wonderful set of the presentation, which will cover the different topics and different domain. All the presenter have give their best inputs in terms of a presentation and the question answering. And we will continue the same for the next session. All the very best to the conference.
Yes, thank you very much. And with this, we conclude our session. I would request everyone to please turn on their cameras for a quick snapshot. Yes, thank you, everyone. Have a great day ahead. Thank you.
Thank you.
Bye, everyone.
Thank you very much.
Bye bye.
Thank you.
Thank you, ma'am.